In the next two videos, we will talk about Intel architecture 32 processor. We already introduced the mode of operation. In this video, we will talk about the basic execution environment. So next video, we will introduce floating point unit. So what are in the basic execution environment? So the basic execution environment for IA32, including the general purpose registers. So that's the registers we will show you what they have in the 32-bit environment. And also we will have the different status flag. So remember earlier when we talked about the instruction execution in the CPU, every time after the instruction, we will do some calculation. Then we say we will update the status flag. So those status flag is important from the execution environment. So then we will all talk about that. Then you will see those registers, how they will do for the special purpose. So before we introduce those registers, let's talk about the first thing about the memory. So the memory actually is addressable. Remember before in C++, we told you we define a variable, but this variable actually is store the memory location. So then when we want to access the value, they automatically dereference from that memory location. So that's very important. All the memory, they have their own address. So remember we talked about we have two basic operation modes from IA32. Most of the time we have the protected mode. So this protected mode actually is the processor run on multiple programs at the same time. So remember we told you each program, the processor allocates specific segment for each program. So that's why they won't interfere each other. So each process, actually they have up to, so you see here, it's up to 4 gigabyte memory. So let me talk about here why we say they are up to 4 gigabyte memory. So this one we need to think about the math. Each process has up to 4 gigabyte memory. It came from in the 32-bit environment. All our memory address will reside at most at 4 bytes. So you know 4 bytes equal to 32 bits. So the memory address, they are unsigned integer. Because it's meaningless, we use the sign for the negative. So since you have 32 bits to store the memory address, so that's why the value will be up to 2 to the 32 power, right? So 2 to the 32 power, that's because your address, your location only can store 32 bits in the memory. So the biggest value will be 2 to the 32. So 2 to the 32 actually mean what? 2 to the 32 mean 4 times 2 to the 30 power. Okay, so remember that's the exponent operation, right? Exponent. Yeah, I need to make the exponent. 2 to the 32 equal to 4 times 2 to the 30th power. And this 30th power is the gigabyte. We talked about before, we say 1K is 1000. So that's 10 to the 3rd power. Megabyte is 10 to the 6th power. Gigabyte is 10 to the 9th power. And also in the binary system, actually 1K is 2 to the 10th power in the binary system. That's our definition. Because 2 to the 10th power equivalent to 1024. It's almost 1000. So that's why here you can see the 2 to the 30th power actually equal to 1 gigabyte. So that's here we show you the processor memory, because at most we can have 4 bytes to store the memory address. So that's why the up to 4 gigabyte memory allow you to use. So that's what we say here in the protected mode. They're using the 32-bit address. So the regular protected mode, we have up to 4 GB in memory. And also we told you, right, we also have the virtual 8086 mode. So for the virtual 8086 mode, the program actually only can have 1 MB memory area. So that's they allocated. And in real address location, they only allow the same thing is 1 MB. So 1 MB actually you can see that's 2 to the 20th power. They're using the 20 bits as the address. So that equivalent to in the hexadecimal from 000 to 5F. Because the hexadecimal, each character, each bit represents 4 bits in binary. So that's how we show here in the real address mode, or even in protected mode. If do the virtual 8086 mode, they only allow at most 1 MB memory because they're only using 20 bits in the address. So after you can understand about the memory can be addressable, so then you can see later when we show you, we're using the general purpose register. They can using to store value, and sometimes they can use to store memory address. So that's the reason our memory address, they only can allow your memory up to 4 GB in 32-bit environment. Of course, later when we talk about 64-bit environment, they will have larger number. Okay, finally, we will start talking about the register. So basic program execution register in the 32-bit environment, they have 8 general purpose registers. The EAX is what you heard before. Then not only have EAX, EBX, ECX, EDX. So that's usually those 4 registers we're using for the calculation purpose. So E, you can see that stands for the 32-bit environment. So then here you have the other 4 general purpose registers, but those 4 is using for the stack memory. This one we will talk about more in chapter 5. So this one called basic pointer, then stack pointer, then the source index and the destination index. So later in chapter 3, we will see the general purpose register first. Then in chapter 5, we will introduce the stack memory. So then you will see that. Then also this 8 general purpose registers, we also have the other one is the EIP. So this EIP stands for the instruction pointer. So did you remember in Monday we talked about in CPU, when you have your instruction will be work for the next available instruction. Actually, it's using the instruction pointer to point to that location. We know the next instruction will be execute. And later we will show you the status flag actually is reside in the E flags. In E flags register. So the segment register actually we don't use for this class. In this class, we will use the EAX, EBX, ECX, EDX a lot. So let's go further to talk about that. So each EAX, EBX, or ECX, EDX, they refer to 4-byte location. So those general purpose registers primarily using for the arithmetic and data movement. So that's why you see when we're using the add or move instruction, so we use the EAX and EBX for the calculation. So here let's see, this one is EAX. In the 32-bit environment, if your register, you use the EAX name to refer to, you will refer to that whole 32-bit. So that's why EAX, EBX, ECX, EDX refer to the location for the 4-byte location. However, remember we told you, x86 actually not only from 32-bit environment. Before 32-bit environment, we have 16-bit. After 32-bit, we have 64-bit. So from the revolution for the hardware size, when we start from the 16-bit, moving forward to the 32-bit, some of our program or source file run on 16-bit environment, we should make sure they also can run after they upgrade to the 32-bit environment. So that's why in the 32-bit environment, even we call EAX is the whole 4-byte. But we allowed use in the assembly language, you also can using the AX. So when you're using the AX, actually you are referring to the first 2 bytes from the EAX location. Okay, so did you get what I mean? That's very important. When you're using the EAX, you are referring to the whole 4 bytes. When you're using the AX actually doesn't mean you have another 2 bytes. AX actually means the first 2 bytes from the same location EAX referred to. And also we allowed the AX can be also accessed as a 1 byte as well. So we have the AH and AL. So the same thing, even we show you kind of like AH, AL like this, right? But this AH actually is the second highest byte from the EAX. So the AL is the first lowest byte from the EAX. So actually they are referred to the same location. Just EAX refer to 4 bytes. AX refer to 2 bytes. AH equal to the higher 1 byte. AL refer to the lower 1 byte. So this apply on the EBX, ECX, EDX as well. So that's very important because sometimes we want to save in the 4 bytes. Sometimes we only need to save 1 byte. So that's we're using the specific registers to store the data we want to save. So the same thing earlier we talked about ESI, EDI, EBP, ESP is for the process the stack memory. But also those 32 bits actually in the 16-bit environment, they're using the SI, DI, BP, and SP to refer to that. We will talk about more about each register, how we use that in the future chapter. But here let's talk about the general use for those registers. So those registers usually we're using for EAX is for the accumulator. So they are automatically using by the multiplication and the division instruction. So that's the mode or div we will talk about in chapter 4. In assembly language, we also can write the loop, but the loop has to have the specific counter. So that's ECX. So then ESP stands for the stack pointer. So the stack here refers to the stack memory. So when we access the stack memory from the procedure, then we're using the stack pointer to refer to that. So the other important register we call the extended frame pointer. So that's for the base pointer for the stack memory. So then you have ESI, EDI, that's for the index register. The using for the high-speed memory transfer instruction. So that we will talk about more in chapter 6. And we also have the segment register. So in the real address mode, the 16-bit segment register indicates the base address for the pre-assigned memory area. So in the protected mode, segment register hold a pointer to the segment descriptor table. So in this class, actually, we don't talk about the segment that much. So you just need to know CS, DS, SS, they are referred to the segment register. So then the last one, we talk about the EIP. So that's instruction pointer. So they will contain the address of the next instruction to be executed. Then we have the E flags. So this E flag actually is the status and the control flags. So each flag actually is only single binary bit. So for each single binary bit, if that flag is set, that means the bit equal to 1. If the bit equal to 0, that means they are clear. So that's all the status flag we have we will introduce in this class.